In order to be successful in this voice thread, in this lesson, your factoring methods are crucial. It's important that you understand all of those factoring methods. Also, your basic algebraic manipulation of expressions, add, subtract, multiply, and divide. That is also important in order to be successful in this voice thread. What's this voice thread all about? We're going to review what you did in elementary school when you added and subtracted fractions. And we're going to look at examples that involve rational expressions. A reminder that a memory aid is provided for you so that you know all of the steps for manipulating rational expressions. In the next tile, the link is provided to that memory aid. I hope it helps you. Once more, I'm going to bring you down memory lane. When you were in elementary school, when you added fractions, do you remember that you had to have a common denominator before you added? Well, in this particular case, we have a common denominator. We have 3 over 11 plus 2 over 11. The denominators are identical. Therefore, what you did is you kept that denominator and you added or subtracted the numerators. Here we're adding 3 plus 2. Our final answer then, we kept that denominator and we add the numerators. The same goes for algebra. In algebra, whenever you need to find the addition of rational expressions. Now we're going to begin with identical denominators. We keep the denominator and we add or subtract the numerator, being careful with the rules of algebra. That's the extra part here. So if you had 2 over x minus 9 over x, we've got fractions, we've got rational expressions. The same rule applies. We must have a common denominator, and we do. We keep that lowest common denominator, and we add or subtract the numerators. Here, it's subtraction, 2 minus 9. Now you know that 2 minus 9 is negative 7. So our final answer is negative 7 over x, with a reminder that the denominator can never equal to 0. Therefore, x cannot equal to 0. Now let's look at more examples. These are becoming more complex, but the idea stays the same. We have rational expressions, we're subtracting. We must have a common denominator, and we do. The denominator is x minus 1. Now, my recommendation is that you begin by placing brackets around that common denominator and the expressions in the numerator, because you're working with algebra, and especially when it's subtraction. And that's what I mean by you've got to be careful with your rules of algebra. So I recommend that you place those brackets. Now that we have a common denominator, we can keep that common denominator and we subtract the numerators, being careful with the rules of algebra. And that's where the brackets come in handy. In front of the brackets here, there is no sign. That's understood that it's positive. Therefore, that remains x plus 2. But here's the part that you've got to be careful with. You're subtracting a binomial. You've got to subtract both terms that are inside the bracket. So in reality, you're subtracting 5x and you're subtracting 9. Notice how we kept that common denominator. Now we can simplify the numerator. Collect our like terms, keep that variable of x. It's understood here that it's 1. 1 minus 5 is negative 4. So we've got negative 4x, and positive 2 minus 9 is negative 7. And we keep that lowest common denominator. We have our result of our subtraction. Keeping in mind, and I won't repeat this for the other voice threads, the denominator can never equal to 0. Let's go up in level of difficulty. When you were in elementary school, you had to add fractions with different denominators. You had to find a lowest common denominator. If we look at these two denominators, 2 and 5. Now, I know in your head you're going to say, oh, that denominator is 10. You're absolutely right. The denominator, the lowest common denominator is 10. But why is it 10? In order to find the lowest common denominator, if it's a factor in the original denominator, it's a factor in the lowest common denominator. 2 is a factor in the lowest common denominator. 5 is a factor in the original denominator, therefore it's a factor in the lowest common denominator. What I've just said is going to be extremely important when you're adding or subtracting rational expressions. The next slide will help you continue. So what you learned in elementary school is that once you had your lowest common denominator, your original denominator changed, and you had to find out how it changed. You changed that denominator by multiplying by 5. Well, you've got to perform the same operation to the numerator. In reality, what you're doing is you're multiplying by 1. 5 over 5 is 1. We chose 5 because the original denominator changed to the lowest common denominator by multiplying by 5. Therefore, we call this an equivalent fraction. Notice from 5 to 2 times 5, the denominator changed by multiplying by 2. Therefore, you must multiply the original numerator by 2 as well. Therefore, we call this our equivalent fraction. If I go to the next slide, I multiplied my denominators. My lowest common denominator is 10. I simplified my numerators. 1 times 5 is 5. 3 times 2 is 6. Now I've got common denominators. Now I can go ahead and keep that denominator and add the numerators. My final result is 11 over 10. What if algebra was involved? Here are your steps. I'm not going to read them for you, but I'll walk you through these steps in the examples provided in the following slides. I'm subtracting rational expressions. First step, I've got to think. When I'm adding or subtracting rational expressions, I need a lowest common denominator. I don't. Therefore, I verify to see if it can be, if any expression can be factored. That is either the numerator, the denominator, or both. They cannot. The next step, find the lowest common denominator. How do we find the lowest common denominator? And this is what I always do. I always place my two lines, my fraction lines, and I look at each denominator. X minus 1 is a factor in this denominator. Therefore, it will be a factor in the lowest common denominator. X is a factor in this denominator. Therefore, it will be a factor in our lowest common denominator. I just found my lowest common denominator. If it's a factor in the original denominator, then it's a factor in the lowest common denominator. Do you remember what the next step is? I found my lowest common denominator, x times x minus 1. Now keep it in factored form. Then you must find equivalent fractions to get from x minus 1 to the lowest common denominator. How did that change? You multiplied by an expression. What was that expression? It was x. Therefore, you must multiply the numerator by x as well. This denominator from x to the lowest common denominator of x times x minus 1. You multiplied that denominator by x minus 1. Therefore, you must multiply the numerator by x minus 1 as well. We must find equivalent fractions. We've got our equivalent fractions. Do you remember what the next step is? The next step, once you've found your equivalent fractions with those lowest common denominators, the next step is to be careful with your rules of algebra. Simplify those numerators using the rules of algebra. So x times x is x squared, and 2 times x minus 1, you're going to multiply the 2 by both terms. 2 times x is 2x. 2 times negative 1 is negative 2. This is where you have to be careful. You're going to keep that lowest common denominator, which is x times x minus 1. That doesn't change. You're subtracting. Beware, you've got to subtract 2x and subtract a negative 2. That will become positive 2. Now, we've got x squared minus 2x plus 2. over x times x minus 1. Now at the end, once you've simplified that numerator, you've got to verify because maybe you can reduce your fraction to lowest terms. Would you think about that? Is there a way you can factor the numerator? Is it possible that it's an easy trinomial? No, it isn't possible. It cannot be factored, but you've got to verify that. Sometimes it can be factored and you can reduce to lowest terms. So we have our final result for our subtraction of rational expressions. So here are two more examples that I will walk you through it. But I would like you to try it first at your desk. Pause this voice thread, try them using the steps that I have provided, and then verify with the explanations that I will provide. Good luck. We're adding rational expressions. Whenever we add rational expressions, we must make sure that we have a lowest common denominator. But first, remember, if you can factor either the numerator, the denominator, or both, go ahead and do that. We don't in this case. We've got to find a lowest common denominator. Remember, if it's a factor in the original denominator, it's a factor in the lowest common denominator. X plus 3 is a factor in this denominator, therefore it's a factor in the lowest common denominator. We just found our lowest common denominator. Do you remember what to do next? You had to find equivalent fractions because you changed the denominator. This denominator was multiplied by x plus 3. Therefore, you must multiply the numerator by x plus 3. This denominator was multiplied by x minus 1. Therefore, you must multiply the numerator by x minus 1. What do you do after that? You've got to think of your rules of algebra and simplify the numerators. I've got a 2 in front of the bracket. I'm going to multiply 2 by both terms inside the bracket. 2 times x plus 3 is 2x plus 6. Here, 3 is in front of the bracket. I'm going to multiply 3 by both terms inside the bracket, which gives to me 3x minus 3. I have a lowest common denominator. I've simplified my numerators using the rules of algebra. Now I can go ahead and add. I can add 2x plus 6 plus 3x minus 3. I can collect my like terms so that I can have my numerator. 2x plus 3x is 5x. 6 minus 3, 6 minus 3 is positive 3. Therefore, my simplified expression is 5x plus 3 over x minus 1 times x plus 3. Now I've got a task for you. Why don't you try this subtraction without looking at the memory aid tips that I have provided, without looking at all of those steps you're subtracting. Do you remember what all those steps are? Do that at your desk, and then you can verify with the solution I'm providing. So did you remember that you had to find a lowest common denominator? If it's a factor in the original denominator, it's a factor in the LCD. If it's a factor in the original denominator, it's a factor in the LCD. In this particular example, the lowest common denominator is x plus 1 times x minus 1. That's the first step. Find the lowest common denominator. Then find equivalent fractions. You observe what was multiplied by the original denominator to get the LCD. It was multiplied by x minus 1. You must do the same operation in the numerator. We call that equivalent fractions. Here, the denominator changed by multiplying by x plus 1. Therefore, you must multiply the numerator by x plus 1. Why don't you go to the next slide to see what comes next? You found your lowest common denominator. You found your equivalent fractions. Now, what you have to do is simplify the numerators using the rules of algebra. Let's start with this numerator. If we're going to use the rules of algebra, we've got to multiply, we've got to distribute 2x by both terms inside the bracket. 2x times x is 2x squared. 2x times negative 1 is negative 2x. Then the second numerator, I'm going to distribute 3x by both terms inside the bracket. 3x times x is 3x squared. 3x times 1 is positive 3x. Take these steps one at a time. Simplify the numerators. Then you've got to be careful with subtraction. Did you try that before? Look at my next slide. Notice how I kept the lowest common denominator. That doesn't change. Then I rewrote what I see in the numerator. 2x squared minus 2x minus. And I've got to remind myself that I'm subtracting both terms. Brackets will help me remember that. Then, what do I do after that? I've got to distribute that negative to both terms inside the bracket. So that will be minus 3x squared minus 3x. We've gotten rid of the brackets in the numerator, but in order to continue simplifying, I must collect like terms. If I'm going to collect like terms, here, my x squareds are the same. I keep that x squared and I subtract 2 minus 3. Then I continue collecting my like terms. X, keep the x, minus 2 minus 3. I now have negative x squared minus 5x. Now you might think we can stop, but after you've simplified that numerator with the lowest common denominator, you've got to verify. Maybe a rational expression can be simplified further. And do you remember, in order to simplify, you need to factor. So why don't you try and factor that numerator to verify if you can simplify or reduce this rational expression to lowest terms. I can find a GCF. GCF would be negative x. Negative x is common to both terms. When I divide negative x into both of these terms, I get x plus 5 is the other factor. So we verify. Are there any factors that are identical in the numerator and the denominator? The answer is no. Therefore, this is your fully simplified rational expression after we subtracted. In order to be confident, keep these steps in front of you at all times. Keep on practicing. It's not enough just to watch me doing it. It's important that you continue practicing. Good luck.